In this video, I'll be writing up a sample application or word count for Hadoop streaming. Recall that in the MapReduce version of word count, you will require a mapper to tokenize an input line and emit word, 1 for every word in the line. A reduce will aggregate all the key value pairs with the same key and then sum up the values to produce the final result. Although Hadoop MapReduce is an entire framework in Java, I'll use something called Hadoop Streaming, a way by which you can use a custom program or an executable as the mappers and the reducers in your job. And these will process the data over the standard input and output pipes in Unix. For those who are familiar with the Unix or POSIX commands, the processing can be represented with this command: cat input, pipe through the map program, pipe through sort, pipe through the reduce program, and redirect to output. In the example shown, we simply need to write the map program and the reduce program. All of the other operations of handling the input, sorting the outputs from the map, and writing the outputs from the reduce is handled by the framework automatically. For this video, I'll show you examples in Python and Java, but feel free to use any language that you're comfortable with, as long as you can use Unix pipes for input and output, and 2, the required framework works with the EMR AMIs that Amazon uses. So let's take a look at the Python version of the map program first. The Python version is quite simple. We simply split the input line from standard input. We might have to strip away any leading or trailing white space before we do that, and then we split the line for the individual words, thereby tokenizing the line on each word. And for each word that is in the list of words split, we just simply print out word, 1. The reducer for this is a little more complicated because we need to aggregate all of the values by key. So we just initialize a few variables, look at the input from standard input. This is going to be the input coming in from the map task. Again, split this line. A line will also only have 2 tokens now, since it's been already processed by the map. So we assign them to the variables word and count. This is split by tab. Get an integer value from the string value of count. If there is some error, we'll just skip this line and continue. This is useful in, for example, when you're doing large data sets and maybe you have a value that's not exactly parsing as it. So if there's some weird error that shows up during the processing, let's just skip that line and continue. What we also do is we have sorted output coming from the mapper, so we can look for a condition where the word that we are looking at right now in the current line, if it matches the previous word or not. If it does match the previous word, we're just going to update the count. But if it doesn't, then we need to print out the word and the count of that word till now. It's a simple counting application. And then finally, we just make sure that if there is any residual word that did not get printed within our loop, we want to make sure that that's printed as well. Okay, now that we have this Python program, let's test it out. And it's important to test these programs out locally on your machine before you fire up an expensive EMR cluster. And to test them out, we are going to use the same Unix format that I described earlier in the video. First, let's take a look at our input. We have an input file which is some dummy paragraph of an essay on jelly. Now what we can do is we can let's make sure that I have the Python programs ready. The flexibility of the Unix pipes allow you to test the mapper and reducer individually. Let's test out the mapper first. So let's just cat the input file, right, and then pipe through the reducer. So now you should see the output of the reducer for the paragraph that I showed you as the input. So every single word has been tokenized, and then 1 is output for this word, which is exactly what we want the mapper to do. So let's continue this. We'll pipe through sort, and then what will happen is we'll have a sorted list of key value pairs that are output from the mapper. This is similar to the shuffle phase. And then finally we'll test out with our reducer. Now what will happen is any word that appears more than once in the sorted output will be aggregated, and you should be able to see the final count of the words as well as their frequencies. Okay, now let's look at the Java version of word count that we can use in streaming. Now be aware that this is completely different from the actual Java MapReduce versions of word count. In the streaming version for Java, we simply read input key value pairs from standard input and output them through standard output. It's just like the Python program. I am covering this just for the benefit of any Java programmers out there who may not have experience with Python and want to complete this project by writing a Java program. It's important to note that using Java for streaming is actually is slightly counterintuitive. Because MapReduce is a Java-based framework, you typically write your program using the Hadoop libraries in Java, and then the mappers that you write will be a subclass of a Hadoop mapper class, and the reducers will be a subclass of a Hadoop reducer class. But like I mentioned, the mappers and reducers that we are writing now for streaming simply use the standard input and standard output for reading and writing key value pairs. This is just for use inside Hadoop streaming. So the Java programs are exactly like the Python programs that I explained earlier, and if you'd like to see the source, there should be a download link on this video. Again, what we do is we make sure that we set up input stream reader on standard input. We read each line from standard input and we tokenize them for individual words. And then for each word that appears on the line, we just print the word tab space 1, and that's it. The reducer version of the Java program is very similar to the Python program. All we're doing is setting up an input stream reader on standard input. We initialize our variables, and then for each line of input that appears on standard input, we split it into the word and count, since it's coming in sorted fashion from the mapper. And then we check whether the current word that we're looking at equals to the word on the line. If it does, then we just increment the counter. Otherwise, we simply output the word followed by the count, because the word has changed. And finally, we want to make sure that if there's any remaining word, we want to make sure that that's not missed out. So that's the Java version of the word count reducer. Let's see if we can run these programs in a local machine. Now, once you have the Java files written up, obviously you need to have them compiled and packaged into some kind of jar so that we can ship it into the cluster for it to work. So let's go ahead and compile the programs using Java. So the command is java c. Let's just compile both programs together, and we now have the class files for the mapper one for the reducer. Let's create the jar file. So let's just say jar cvf word count.jar, and then let's just add all the class files that we just created right now, and the jar file will get created. Now, just like the Python program, we should be able to test this locally on our machine from the command line before we ship it out into the EMR cluster. So let's just do the same. Let's cat the input file. The input is ready. Let's pipe that through the map program, and for this we'll have to say Java class path word count.jar, and then let's give the name of the class that we want to execute, which is word count mapper, right? So the map class works correctly, just like the Python version. Pipe through sort, and then let's test the reducer as well. So class path word count.jar word count reducer, and yeah, our program works perfectly fine. I think these are now good for us to test out in the EMR cluster. It's very important to note that you should spend some time testing your map and reduce tasks locally on the command line before you launch an expensive EMR cluster. So that way you can get rid of all of the, any typos or any issues in, whichever programming language you're using. You want to make sure that you get them cleared and out of the way, and all fixed before you launch an EMR cluster. In the next video, we'll show you how to run these programs on an EMR cluster.